All right. Given one or more roots of a polynomial, find the remaining one. So if we're given the roots, specifically we're given the root here on the first one is -2. If that's our root, that would come from a factor of x plus 2. A couple ways to think about it. If we have x minus a, then our a value is -2 if that's our root. And so we would have x minus -2, which is x plus 2 as a factor. Another way is to remember that roots are where, on a graph, roots are where it hits the y-axis. These are also called x-intercepts. So if it's hitting at -2 on our function, that's going to be uh, where the y value was equal to 0. So then, hey, how would I make this equal to 0? I had x plus 2 equals 0. I would subtract 2 from each side and get x equals -2. So a couple different ways to think about that. And we'll be much more explicit as we go on. But just there we go for right now as a bit of a preview. All right, so if we have a root of -2, so we got -2. Let me rewrite that. -2 is our root, and then we're going to divide that into 6x cubed plus 11x squared minus 4x minus 4. So our coefficients here are 6, 11, -4, and -4. And off to the side, I'm going to write down that our first factor, so that's x plus 2. And whatever our quotient is, I know that this should divide out evenly, but then whatever our quotient is, that will be the other factors over here. And so let's go through that process. 6 comes down, -2 times 6 is -12. Add them up, we get -1. Multiply those out, we get 2. That's -2, and -2 times -2 is +4, which adds to 0. And we knew that it should be 0 because we've already been told it's a root. So we know that x plus 2 is a factor, meaning it does go in evenly with a remainder of 0. Now this was 6x cubed, meaning this is 6x squared minus x and then plus 2. So here we've got 6x squared minus x minus 2. And this part here, now that we've got our first factor, we would have to factor out the 6x squared minus x minus 2. And that does factor out, depending on how you do your factoring, whether you do box method or something else there. Let me make this a little bit bigger. Sorry, so whether you use box method, whether you use grouping, however you go about factoring, that's fine, but let's go ahead and do that now. So we're going to have 6x squared minus x minus 2, and we need to figure out what that is going to break up into its two terms. So what multiplies to give us -12 but adds to give us -1? Well, hopefully we can see it's going to be -4 and 3. So -3 or +3x and -4x. We'll rewrite this as 6x squared minus 4x and plus 3x minus 2. And then let's factor out. Again, this is factoring by grouping. If you prefer using the box method, then go right ahead. Looking for my common factor here is going to be 2x, which leaves us with 3x minus 2. And then over here, we've got to factor something out to give us 3x minus 2, and we can factor out a -1, which leaves us with, oh, sorry, a +1, sorry about that, +1. So we end up with 3x minus 2. Again, these two pieces here need to be the same, meaning our factors are going to end up being 2x plus 1 times 3x minus 2. And now we've got our other roots, or we can get to our other roots. So I said find one or more roots of the remaining roots of the polynomial. So here we would set these each equal to 0 because we would have x plus 2 times all that. That is our original equation, the 6x cubed, so on, so on, so on, in its factored form, and that was set equal to 0. Our first one is negative 2. There's the root we already knew. This one, set it equal to 0, so you'd subtract 1 and divide by 2 gives us negative 1/2. And on the last one, add 2, divide by 3, and you end up with 2/3. So our roots on this one are going to be x is equal to our other two roots. We're already given the one, so positive or negative 1/2 and 2/3. All right, let's continue on with the next problem here. We've got, we're given these roots here where, let's divide them out one at a time. So if I had 4, there's my first coefficient, and actually let's look to see if we have any missing coefficients. So the 4th power, 3rd power, squared, first 0 power. So we're not missing any terms. Don't need to add any zeros. So we have 4, negative 4. Now I'm just taking my coefficients, negative 25, 1, and 6. And you can divide out that negative 2 root. So we have 4, negative 8, negative 12, positive 24 gives us negative 1, 2, which is 3, and negative 6, giving us 0, which is what we thought we should have. We thought we should have 0 because it's a factor, and we do. Now this would be 4x cubed, so on, so on, so on. However, we've got another factor to divide out, so I'm just going to continue right there on my process. Same problem. And you could rewrite this just to be real explicit about it, but I already have my coefficients for the next, I already have my coefficients, so I'm just going to keep on going. So bring down the 4, and that gives us 12, 0, 0, negative 1, negative 3. And again, this remainder here I'm not going to be using because that was the remainder. And we end up again with a remainder of 0. All right, so to write this out a little more explicitly than this full term or expression on the left, again set equal to 0, but the left of the equation, we factored out a negative 2 root, so that was a factor of x plus 2. Then we factored out a root of positive 3, so that was a factor of, or we divided out a root of positive 3, so that's a factor of x minus 3. And now we're left over with 4x squared plus 0x minus 1. And that's still equal to 0. All right, we already know these roots here. This is going to be root of negative 2, and this is a root of positive 3. We already found those. Here we're going to need to keep on factoring, and this is going to be the difference of squares. So it leaves us with 2x plus 1 and 2x minus 1, still equal to 0. And we do still have the x plus 2 and the x minus 3, but those are just, we already know our roots, so we can kind of ignore them right now. And here we'll add 1 to each, or sorry, subtract 1 to each side, divide by 2, so negative 1/2, and over here we'll add 1 to each side, divide by 2, so positive 1/2, meaning that our remaining factors here, we're given the negative 2 and 3, and our remaining factors are going to be x is equal to 1/2 and negative 1/2. All right, hope that helps.